Problem of the day number 4. The 4-digit number A55B is divisible by 36. What is the sum of A and B? And remember that A and B are both representing digits of the number. And so the first thing you need to note is that when a number is divisible by 36, it's going to be divisible by every single number that 36 is divisible by. So for example, being divisible by 36 means that it's also going to be divisible by 2, because 2 divides 36. Same thing with 3, 4, 5 does not divide by 36 because 36 does not end in a 5 or a 0. 6 does, but we don't need to write 6 because being divisible by 6 is the same as being divisible by 2 and 3, so that would be redundant. But being divisible by 9 is also works. Okay, so let's look at what each of these tells us. So this problem is very much a logic problem, just as much as it is testing us on divisibility rules. Okay, so if a number is divisible by 2, that tells us that the last digit is even. So that means that B, which is the last digit, is an even number. Even number. So that tells us that B can be 0, 2, 4, 6, or 8. It can't be 10 because 10 is no longer a one-digit number. Okay, if a number is divisible by 3, that tells us that the sum of all the digits is going to be divisible by 3. So sum of the digits is divisible by 3. So that means that A plus 5 plus 5 plus B has to be divisible by 3. So for example, 3, 6, 9, 12, 15, and so on. But you can see that 5 and 5 already gives us 10, so it has to be a number that's divisible by 3 and larger than 10. So the first one would be 12. It could also be 15 or 18 or 21 or 24 or 27. And I'm going to stop there, because remember, A and B are both one-digit numbers. So the largest number that B could be is 8, which means that the largest digit that A could be would be 9, because that's the largest one-digit number. And so together that'd be 17 plus 10, so that's 27. So that's the very, very largest that they could be. And 27 is the largest number that's going to be divisible by 3. Okay, and being divisible by 4 tells us that the last two digits, that 5B, so last two digits, is going to be divisible by 4. So in that case, we're talking about the 5B, it has to be divisible by 4. So for example, 52 or 56. Those are the only 50-something numbers that are divisible by 4, because 50 is not, 54 is not, 58 is not, okay? And lastly, for being divisible by 9, tells us that the sum of the digits is divisible by 9. Digits divisible by 9. And this is very similar to being divisible by 3. So we have that A plus 5 plus 5 plus B is going to be a multiple of 9. So again, 5 plus 5 gives us 10, so it has to also be larger than 10. So the first one that's larger than 10 but divisible by 9 is 18 and 27. Those are the only two that are larger than 10 and still divisible by 9. Okay. And so we want to put all these things together to figure out what the number could be. Okay, so we know that, let's see. So we know for sure that A and B has to add up to either, so let's look at the last clue. So A plus 5 plus 5 plus B equals 18, or it could equal 27. So because this is 10, that means that if we subtract 10 on both sides, that means that A plus B can either be 8 or it could be 17. So let's start by looking at if A plus B equals 17, because the only way for that to happen is if B was 8, because remember B has to be an even number, so 0, 2, 4, 6, or 8, and that means that A would have to be 9. That's the only way for A plus B to equal 17. But if B is 8, that actually contradicts being divisible by 4, because B being 8 means that the last two digits would be 58, and 58 is not divisible by 4. So that means that A plus B cannot equal 17. And let's make sure that A plus B equals 8 does not contradict anything else that we have. So if A plus B equals 8, let's work with being divisible by 4 first. Okay, so that means that, let's say B is, for example, 2. Okay, that means that A would have to be 6 to add up to 8. Okay, and let's see if that contradicts anything. So the last digit, the B, is still even, so that works. All of the digits added up should still be divisible by 3. So 6 plus 2, that's 8, plus the 10 from the 5 plus the 5 gives us 18. So that's still divisible by 3 and is also divisible by 9. And because the B is a 2, it's going to be divisible by 4. So that doesn't contradict anything. So that works. So that means that if A is 6 and B is 2, that tells us that the number is 6552. And if you put that in your calculator, you'll see that that is divisible by 36. What about, what's another option? So for example, B could also be a 6, which means that A would have to be 2 in order for them to add up to 8. And again, that works for all the different rules. It'll still be divisible by 2 and 3 and 4 and 9, and that would give us the 4-digit number 2556. And again, if you put that in the calculator, you'll see that it is divisible by 36. So that means that A plus B have to add up to 8. And then you have 2 different possible 4-digit numbers that will be divisible by 36.